Finish him. Kill the guy now. Grab the gun. What? What is this? Good day, sir.
You are watching Jackie Pan in my house.
So it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you'll be fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have you last semester.
We by pounds on you. Very stupid. Oh, yeah, change that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.
Okay, good day everyone, and this is the second lecture on MTH 201, Mathematical Method 1. Last class we discussed the properties of power series, and under this we look at how can we expand a series using Maclaurin's and Taylor expansion. But this afternoon, we are going to continue and we want to discuss convergence series. Convergence series. What we want to look at in this concept is that we want to see what are the conditions by which we say a series is convergent. Don't forget, when we have the series of the function, the series S1, S2, S3 to Sn of the sum of the partial sum of the series. This is all these one are sequence, but if I change them to the partial sum, then I will say they will turn to series. Then I will say this thing, if I had all the partial sum of this, and it converges to S. If this sum converges to S, I can write this partial sum as limit n tend to infinity, or I'll just write it in partial sum. I write the sum of I is equal to 0, I is equal to 1 to infinity over ui is equal to S. Then, don't forget, I've mentioned this thing before in the class, that if I have the partial sum of this series, of this sequence, it becomes series. The partial sum to infinity, if it gives S, then I will say this S is the point of convergence of all these series. This S is the point of convergence of all these series. Now, don't forget, I said the point at which, or the limit at which this series converges. Now, I call this one a convergent series. If this convergent series converges to S, the point at which it converges is called the point of convergence. The point of convergence of that series and the limit of that series. Now, that is what we said about the convergence series and how can a series converges. But what are the conditions for convergent series? What are the conditions for convergent series? What are the conditions that a series given like this, a series given in this form, what are the conditions for which this series to be converges? Now, I told you to read 2.6. That is why I'm not reading notes here. I want to summarize what you have read. If I have this sequence of partial sum of the series, I have this partial sum of the series, this sequence, and I have my A1, yes, plus A2 plus A3 to AN to be my series. These are the sequence, the partial sum of the series, and these are the series now. These are the series itself, represented as A1, A2, A3. Now, I can have the relationship from this sequence and this series. Don't forget that these series are the partial sum of this sequence. Now, I will now have my S1 to be equal to A1. That is, the first sum is the first term of this series here. Then my S2 will now be A1 plus A2. That is, I want to add two terms of this series. Don't forget when you are in secondary school, I told you, bring the idea of your secondary school to this class. If you are told to find the S8, sum of the 8 terms, you have 8 over 2 into 2a plus 8 minus 1, that is n minus 1, into d. Don't forget that one. Now, I'm looking for 8 times, then this one will be plus 7d. What I'm trying to do here is that I want to find the addition of 8 terms. First term, second term, that is S8, third to the 8 terms. But in this case, I have S2. I want to add from 1 to 2. Then if I have 3, S3 now, somebody will know it will be A1, A2, A3. Now, if I have this one to Sn, then this one will give me A1, An. That is sum to nth terms. The sum to nth terms. Now, if I continue to add this one, this n, as n approaches infinity, as n approaches infinity, the limit n approaches infinity here of this Sn will be equal to S. That is the condition for the convergence of this question. If I add all the series in the nth terms, and I look at, don't forget that formula you used to use there. I will not say at n approaches infinity, the large sum, then I will get my S. S now is a constant number value, is a constant value. Then I will say this series converges to S. Then the limit is 60. In other case, if the sum of the infinity exists, I said this one approaches infinity, I didn't say n to infinity. If the sum to infinity of this series exists, I will now write S infinity. If that word exists, I will write S. And this one, this function, this addition to infinity is says to diverge. If it says to diverge if limit n tend to infinity of Sn is equal to infinity, or limit n tend to infinity of Sn is equal to minus infinity. What is the meaning is that if you have negative infinity or positive, I told you it's like this one is approaching from the upper and this one is approaching from below. If I have a series and these two series, we have tested that one in one example, and these two function, these two infinity exist, they will have the same limit. The limit here and the limit here are the same for this. Then if this happens, I will say this series diverges. Now, if a series does not converge and a series does not diverge, what is the name of that series? Then it is called oscillatory series. It is called oscillatory. At that point, it means that the limit of the function will not exist. There will be no divergent there will be no limit of the convergence, then I will say the series is oscillatory series. And that's what is in the note where I asked you to read that time. Now, to power series, what are the conditions? Power series. What are the conditions for power series to converge? What are the conditions for power series to converge? Don't forget, power series can be written as A0 plus A1 x plus A2 x squared plus A3 x cubed to plus AN xn. Or let me assume I have this one to infinity. I have this one to infinity. The meaning of this one can be summarized to be I is equal to 0 to infinity AI x raised to power I. Yes, this one can be summarized in this way. If my A is equal to 0, if my I is 0, that is A0. X raised to power 0 is 1. If 1, x raised to power 1, and so on and so forth, to infinity. Because the sum is to infinity. So if I have this power series, this power series will converge. This power series will converge if the absolute value of the x, all these x, don't forget all these A1, A2, A0, they are arbitrary constant or coefficient of the x. X is the function. If the absolute value of x now is less than r, this r is the radius of the series. It's not a real number. It's the radius of the series. Then this one upon, I will say this is converge. And is diverge. If this one is converge, it's converged. But if this absolute value is less than r, I'll say is diverges. It's diverge. Okay? It diverge. So, look at these two functions. X, absolute value of x here is greater than r. Absolute value of x here is less than r. If I want to write this one in what do you call it? In a range form, inequality. Don't forget, I told you, if inequality comes, it means this function is bounded above and below. This function is bounded above and below. That's the. It means minus r less than x. I want to write it as a bounded function, then the absolute value will leave. The absolute values of this one means this. And this one, this is inside, this is inside this. So if this one happens, then I will say this power series converges. This I will say it diverges. Let's have said in the series. Let me discuss example 2.11. Leave 10. Let me go to 11. Then the question says this. Example. The series is convergent, and that it to 1/2. In a test on exam, I will not tell you, show that it is converges. So I will just tell you, show that this function is converges, and what is the limit of convergence? The limit of convergence is 1/2. What I mean is that the convergent limit that I will get is equal to 1 over 2. So let's go and solve that question. Solution now. Look at what we have. We have the sum to infinity from n is equal to 1 to infinity and 1 over n plus 1, n plus 2. This 1 over n plus 1, n plus 2, I will resolve it into partial fraction. You remember partial fraction? Let me rush to that one so that people will not say, hey, it's just a magic. Resolve 1 over n plus 1, n plus 2 into partial fraction. If I want to resolve that one, I will get 1 over n plus 1, n plus 2 is equal to a over n plus 1 plus 1 over, b over n plus 2. Don't forget the LCM of these two products will be this. And I can write my 1 to be equal to a into n plus 2. If I take the LCM to be this one will take away this to remain this. A will multiply it. Then b will multiply this one plus b into n plus 1. If that is the case, now when n is equal to, look at this, to minus 2. If I take this n plus 2 to be equal to 0, then my n will be minus 2. I will not put n to be minus 2. I will get 1 is equal to a into minus 2 plus 2 plus b into minus 2 plus 1. This brother will be minus 1 minus b, which implies b is equal to minus 1. Also, when n plus 1 is equal to 0, it implies n is equal to minus 1. If I substitute it here, I will get 1 is equal to a into minus 1 plus 2. This one will be 0. Then my a by 1 will be equal to a, because minus 1 plus 2 is 1 is equal to a. You can see my a is 1, my b is minus 1. So that this equation this expression can be written as a sum from n is equal to 1 to infinity 1 over n plus 1 to b n is equal to 1 to infinity. This one will be 1 over n plus 1 minus 1 over n minus 2. This one has changed minus now, because the value of b is minus 1. It's minus. Minus times plus is minus. It's minus 1. Then, if that is the case, this one will give me, now, this one will give me this. I want to write something here. Look at this thing very well. I will write the permutation there. If my n is 1, this one will be 1 plus 1. It will be 2. Minus 1 plus, no, this one is plus. This one will be into n plus 2. It will be 3. This one, if n is 1, it will be 2. This one, so if n is 2, this one will be 3. This one will be 4. Like that. Then this one will be equal to 1 over 2 minus 1 over 3 plus, because this is plus 1 over 3 minus 1 over 4 plus 1 over 4 minus 1 over 5 and so on, and the plus 1 over n plus 1 what I've just done is, if my n remains n, if I take my n to n times, I will have these last times. But look at something. Let me just explain it with days. Today, this is what I'm discussing. The 1st o'clock a.m. of today, 4 p.m. of today. And I want to compare it to what will happen tomorrow. At 1 o'clock, 4 o'clock a.m. today, I will have this brother in my house. When it's 4 o'clock p.m. today, 4 o'clock, this brother will come to my house. 2 of them will remain in my house till tomorrow morning. But 4 o'clock a.m. tomorrow, this brother will come. Can you see they are the same thing? This brother will come and kill this brother here. This brother will die. Then these 2 of them will not appear again. I will have only this brother in my house that day. Till 4 o'clock p.m. of tomorrow, where this brother will come. But in the following morning, this brother will come and revenge and kill this brother. It will continue like that, like that, like that, until it gets to the ear. This brother here will kill one brother before ear. And the last people that will have my house are the first people here and the last people that will come to my house. So that is why this one will be 1 over 2 minus 1 over n plus 2. So if my n, so at this point, if my n approaches infinity, if my n to approach infinity, this one will give me 1 over n plus infinity. And 1 over n plus 2 plus infinity will be infinity. All these one will approaches 0 as n approaches infinity here. Then I will have this one to be limits of this function as n approaches infinity. Our Sn will not be equal to 1 over 2 minus 0. Because all this one will give me approach 0. And this one now is equal to 1 over 2. Can you see? It converges. And the convergence point is 1 over 2. Chicken. That is very simple one. And it's very important for us. Yes. That example 2.13. Yes, I will go to 2.13 before. Let me write the question here. Example. The harmonic. I've explained what harmonic series is. Yes. The harmonic series. Yeah. N is equal to 1 to infinity. Over 1 over n is a divergent series. It's a divergent series. Don't forget, I said it when we were discussing the types of series that the series is form and it's divergent. So how are we going to do that one? What I will do is that I will write. Don't forget, this is just a series given to me, and many of them can come out of this brother. 1 over 1, I can have 1, 1 over 2, 1 over 3 to 1 over infinity, which is 0. Now, I will rewrite this thing. I will write a function for this brother. Then it will look like this. I don't say solution. Let n1 to infinity be divided by xn is equal to 1. I told you. Plus 1 over 2, 1 over 3, 1 over n. Where my n is inside natural number. The question says here, then, this thing is not a Cauchy sequence. Because there are no 2 points here. There are no 2 points here that will cancel each other. Like this. There are no 2 points here that can knock out each other. So it's not a sequence, sorry. It's not a Cauchy sequence. So you remember Cauchy sequence? That's it. So it's not a Cauchy sequence. To see this, I will assume that this is a Cauchy sequence. But don't forget that Cauchy sequence will give me xm minus xn less than this. If I want to say Cauchy sequence is continuous. Now, and this is continuous. At this point, if I pick this function ID, don't forget this m must less than this, sorry, this n must less than this m, or this m must less than this n. But even if m is less than n, or n is less than, sorry, greater than n, we are going to get the same value because of this absolute value. Now, if that is the case, let me pick m. Let me pick m. And now say, to see this, let m greater than n. If m is greater than n, look at it then. Xm minus xn will be equal to 1 over n plus 1 plus 1 over n plus 2 plus 1 over n. Yes. No, it's 1 over m this strand. Sorry. Plus 1 over m. I'll have this. Don't forget, if I change this xm, it means I want to introduce another one. 1 minus 1 will go. 2 minus 2 will go. Then I will have the first increment, the second, and the last one. Each over n. Each of m of them is less than, must be greater than, less than this. Each of them was less than this. So, if that is the, must be greater than that. If that is the case, I will now have, therefore, xm minus xn, xm plus xn to be greater than m minus n over m. I said each time of this must greater than or equal to this. If they are equal to this, then I will have this one to be equal to. Now all this 1, 2, 3, if I take the LCM, I will have, because all the, if this m is greater, it will, this n minus this n will cancel. This, don't look at this 2 and this 1. Don't forget, another 2 will be, another 3 will be here. By the time you add these 2, all this next one will cancel next one, and so this one will remain minus the first n here. This first n is this over m, the LCM. This m, because it's the biggest number. Now, if this is the case, how are we going to do this one? I can divide each of these terms by m. If I divide each of these terms by m, what will I have? Yes. If I divide each of them by m, I will get 1 minus n over m over 1. If I divide each of that term by m. Now, if I look at the next one, is that by considering the special case, m is equal to 2n. We have xm minus 1 over 2. If I pick my xm, okay, let me just say, let m minus n over m will be equal to n over 2n, which is equal to 1 over 2. That is where that 1 over 2 comes from. That is where 1 over 2 comes from. Then, by the time I have this value, I can come back to this brother that I got. I'm not saying xm minus xn is greater than 1 over 2. Is greater than 1 over 2. Which shows that xn is not a Cauchy sequence and converges. I don't know. Our time. And okay. We'll continue from that time, that angle, next class. Thank you. God bless you.
Finish him. Kill the guy now. Grab the gun.
What? What is this?
Good day, sir.
You are watching Jackie Pan in my house.
So it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you'll be fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have you last semester.
We pounce on you. Very stupid. Oh, yeah, change that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.